let's go through liquid 865 smallest subtree with all of the deepest nodes. So let's it gives us a binary tree and return the smallest subtree that it contains all of the deepest nodes in the original tree. So we'll see. Let's look at this example. The 7 and 4, they are the deepest nodes. So we want to find the smallest subtree which contain these nodes. So we'll see. It is this node actually the tree root is the lowest common accessor of 7 and 4, right? So if we have some of the um, if we have those some of the um, deepest nodes more than one, right? If it is only one node which is deepest, then that it will be to the node itself. But it will have more than one, right? We need to find its lowest common accessor. So that will be its tree, right? So when we find this kind of nodes may appear multiple places, for example, or at a node current, right? It can be on its left, the deepest can be on its right, right? If both left and right has the deepest node, then the we are going to have current one as its common accessor, right? So we do from like a divide conquer, right? To from the leaf tree to this root tree. And if the deepest node it's on its left, right? We just need to return the smallest or the lowest common access of the deepest node on its left part, right? So for example, if we have let's say we have, for example, this kind of left tree, right? And we'll say um, tree one and tree two, they are deepest. Then the lowest common accessor is this one, right? For example, this is three. So when we do divide conquer, that node is also we pass a three to its roots. And in order to get its root, right, we also need in order to get its depth, we also need to return another variable, which is the depth, right? So that when we pass from the child, we pass into current one, we'll have the depth plus one every time we pass in, right? So in the end, we can, for every node, we can compare what's the left depth, depth, and the right depth, 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 right? So if both depths equals, then we'll see this the current node will be the smallest tree node, right? And if left is longer, then we just return the left no one, and also the depth we should plus one, right? So this question it is a divide conquer and like the lowest common accessor. And also it says that all of the value are unique. So that means we can return the result in using integer array, right? And also we can use a map which have the value and as key and the tree node as value. In the end, when we return DFSO to the root, right? The first one will be the depth, and the second one will be the tree node, and then we check the result from this map, right? So let's write code for this. You say that tree node is in the range of 1 to 500. So this map we can also write as an array, right? So let's have a tree node. This for this map equals new tree node file, and then we just have, for example, this kind of result equals DFS root, and we need to pass in the map, right? So this kind of DFS private int DFS tree node current, right? So let's see, this kind of DFS return integer array. So that will be the index 0 will be the um, deepest depth, right? Longest depth. And the second one will be the tree node value, right? For the smallest comma or so this is a comma accessor, right? So let's write code for this. So in the end, and also doing this DFS, we inherit the map, right? So in the end, what we need is a return. Which we consult this map result one, right? So in the DFS, what we do, our termination condition is if current equals none, then we just return new int, for example, 0, right? We use because the value is from 0 to 500, so we can use 501 or -1, right? Then we put current one into the map, current dot value equals current, right? And we'll have left result equals DFS current dot left map, and right result equals DFS current dot right map. So what we do is that there are three scenarios. If left result the depth equals right result the depth, then we need to return the new int left result depth +1, right? Or right result +1 and the current data value. And else if left the depth is greater than right the depth, right? Then we just return new int left results +1 and left result 1, right? Else just return new int right result 0 +1 and right result 1. So in the end, just return so that's it. Um, it will be ON time complexity. We will use like this is like a post order traversal, right? Just divide conquer, and this one we can put at here, right? Or after we, but we need to return, right? So anyway, we will see the time complexity will be ON, and space we use a map, right? This is also linear operations. Also the DFS, we have the stack that is also ON, right? Uh, or OHDFS, right? But the map is linear, it's ON, right? Let's write Python code for this as well. Um, so we're going to have for example, this node map equals none multiplied by 501, right? And we have depth and the value equals self dot DFS root node map. So in the end, just return node map value. Let's write the DFS. self uh parent as she no parent. Mm, or we are use optional, right? Because it is possible it is now. And we're going to have this map, right? So if a current is now, just return 0 minus 1, right? And then we're going to have put this into the map equals current, and then left value equals self.dfs current.left in the node map, and the right depth in the right value equals self.dfs current.right. Right. So there are three scenarios. That is, if left depth equals right depth, then we're going to have return left depth plus 1, right? And current dot value. And else if left depth is greater than right depth, then we're going to have return left depth plus 1 and left value. Else we're going to have return right depth plus 1 right value, right? Okay.